Okay, well, I thought maybe before I plot along a line, I thought I might try one more probe a little bit further away from the vent. So bear with me while I go through this. So I'm going to call this one ground 5,000 meters. I'm going to put this 5Ks away from the vent, center of the vent. So we got a point 5,000 away. Apply. So I'm going to close these for the moment. Close that one. So very far away from the vent. Initially, of course, our coarse particles are 0. I want to plot a graph. I want to plot this graph. So this one, this one, this one. Oh no, delete. I did that wrong. We try that again. Plot this one. I want to uncheck this. I want to check this data. This one, copy active selection, then apply. Almost missed a step there. Okay, and then it will plot, hopefully without crashing. Fingers crossed. Wonderful. Well, I can't put it in this awful position over here, but you can just make that slightly larger. And we'll just uncheck everything we don't want. Why isn't it giving me that option? Ah, yes, there we go. So we don't want this for the moment. We don't want fines, we don't want air. Okay, so now the coarse particles 5,000 meters away, so 5 kilometers away from the vent. The coarse particle mass fraction takes a lot longer for this to rise, of course, because it's further away. So only after about, well, let's say half an hour, just before half an hour, do you get much settling of the coarse particles. Okay, so then we get some nice settling here, and again some wiggly bits too. Similarly for the fine particles, well, it turns out it doesn't look like you have very little fine particles at 5 kilometers, in fact. So it looks like for some reason the fine particles probably are still buoyant at this stage. And well, maybe we'll look also at the H2O. There's very little water there. So basically, almost everything at this point, 5Ks from the plume, is coarse particles. Maybe should we try changing this a little bit further? So let's say 20 kilometers. Let's change that to 20. Apply that. And let's see if this automatically updates this chart. Well, that's quite nice, isn't it? So changing that point automatically updated this chart. Okay, so it takes a little bit longer for the coarse particles to settle at 20 kilometers. Let's see what the fine particles are doing. Okay, well, they're still not settling very much. It seems like the fine particles are small enough that they're mostly staying in the atmosphere. You can see that these numbers are completely tiny. Right? Okay. So anyway, well, we can plot these things over time and just watch their evolution. The 500 meters, in fact, was really close to the vent. So that's probably why we had a lot of noise around our parameters there. Okay, so the other thing we can do is we can actually plot. We can plot over a line. Okay, so this button here, plot over line. So basically, you can see here you've got this line here that you can move around and muck about with. I can't see the other side of it. There it is. So we've got this line that we can adjust manually where it's pointing. Of course, that's not superb. I want to adjust this probably just using three coordinates for each point. So let's say 0, 0, 0. In fact, let's go 0, 0, negative 1,000. And then 0, 0. So I think our domain was 35 kilometers tall. So let's go 40 kilometers tall. Maybe let's go negative 5,000 for our other point. So now we've got a line that's going straight up the middle, straight up the middle of our plume, straight between in the middle, down the middle of the vent. So I'm going to apply that. And again, you can see here that it's plotting everything, everything right along this line. So what I'm going to do is again come down here, and maybe I'll just plot the fine particles for now. So, okay, at time 0, again, most of the fine particles are right at the origin. But what I might do is I might skip to the last frame. Okay, and so now this is an hour after the simulation has started. And so you can see that near the bottom, so the x-axis here is the height. So this is 5 kilometers above the vent. The fraction of fines is quite large near the vent. And as we travel further up the plume, the fines fraction is decreasing here. I'm not sure why we're at 5,000 meters there. I'm sure there's some way to change that. Let's change this resolution a little bit and see if that helps us out. There's probably some setting we can fix that. Change the x-axis, but I can't immediately find it, so we'll just leave it for now. Okay, so well, let's also plot the coarse particle fraction. So again, you can see we're starting relatively tall. Oh, I wonder actually, maybe I should set this to 0, this point to 0, and that may actually solve our problem. Ah, yes, okay. So my first point should be at the vent, 0, 0, 0, and then my second point is just into the atmosphere. Okay, sorry about that. Okay, so now you can see at the vent here, the coarse and the fine particle fractions are quite large, and then they of course decrease as you travel up into the vent. Again, let's also plot H2O, and maybe to visualize that, I'll have to turn the others off. And so now we can see along this the plume, the mass fraction of H2O is also decreasing. Air, of course, is increasing, because as we get further up the plume, there is more air entrained and less of the other things. So this is how we can plot along a line. Okay, so I hope that these videos have been informative. In the next series of videos, we'll use ASHEE again, but instead of using the standard ASHEE with air and water vapor being the continuum phases and having 2 particle sizes, we're going to add more, maybe just particle classes. So we're going to add different sized particles to our eruption, and I'm just going to show you how that changes things. I guess the files that we need to change to make that happen. We are not going to add Lagrangian particles yet. That'll be a future video. Just going to add continuum phases for the particles. Okay, I'll see you there.